Another type of function that we want to be able to know how to work with for the midterm is rational functions. We need to be able to find intercepts, we need to be able to find asymptotes, we need to know does it or does it not cross the asymptote, and then pull all that information together to actually be able to graph a rational function. So we're going to take some time and do that here with this function y equals x squared plus 6x plus 8 all divided by x minus 3. And as we do that, we can hit each one of those pieces and know how to work with them. So first thing I want to do anytime I have a function like this is I probably want to factor it out so that I know what my potential zeros or asymptotes are. So if I take a look at that numerator, I could factor that out as an x plus 4 and an x plus 2. And then that denominator is still going to be x minus 3. And if that didn't factor out, we could use the quadratic formula to find the zeros if we needed to for whatever we're trying to find. So looking at this, nothing cancels out, so we don't have any holes. First thing I'd want to be able to find off of this then is any zeros and asymptotes that I have. So I'm going to start with my x-intercepts. And for x-intercepts, we're going to look at the numerator of that fraction. And the numerator would give us zeros of -4 and -2. So at -4, 0 for the coordinate, and at -2, 0 for the other coordinate. Secondly, I'd want to find any y-intercepts that I have. So y-intercepts on this one, I could plug in a 0, and I'd probably use the original form. That way I don't have to multiply anything out, and I can get a 0 plus 8 on the top, so I end up getting an 8 over a -3. So in coordinate form, I can pair that up with a 0 and say 0, -8 thirds. And after that, I'd probably want to find my vertical asymptotes since I have the terms already set up in the denominator factored. So if I set that x minus 3 equal to 0, that can help me find that intercept. Not equal to 3, equal to 0. And then when I solve it, I'm going to get an x equals 3 for the actual asymptote. Now for that last one, it's either going to be horizontal or oblique. If I look back to my original function here, x over x squared, that's going to tell me that it's an oblique asymptote. So to find that oblique asymptote, I need to use my long division to do that, or synthetic, since this is linear, on the denominator. But if I use long division, I've got the x minus 3 down here. I've got an x squared plus 6x plus 8 that I'm dividing it into. And first thing I'm going to do is say x goes into x squared x amount of times. If I multiply that by the x minus 3, I end up getting an x squared minus 3x that I can subtract off. So if I subtract off those two values, the x squareds are going to go away. 6x minus a -3x ends up giving me a 9x, and I can drop down the plus 8. Next thing I do is x into 9x gives me a plus 9. And at that point, I've got my linear function, so my oblique asymptote here is going to end up being y equals x plus 9, what we got off the division. So we got a lot of good information here. We want to be able to put that into a function now, because if I have all this, that's great, and you'll be asked to find those individually, but we need to know how to put that into a full graph as well. So if I take this and try to put that onto a graph, I'm going to start out with our axis, x and y axis. And we said intercepts were at -4 and -2. So I'm going to go left 4 and left 2 for my intercepts. We also had the oblique asymptote of x plus 9. So if I come up here, I'm going to call this 9. It would then stretch out here on the left side and cross at -9. And that oblique asymptote, I'm going to put it in red here, is going to come through and diagonally go through those coordinates. We also said we had a vertical asymptote at x equals 3. So I'm going to come out here to x equals 3 on the right side, put in that vertical asymptote until it looks something like this. Now, if I change my color here, you can put on those intercepts. We had one at -2, we had one at -4. And then our y-intercept was at -8/3, so almost -3. So if I come down just short of -3, I've got that point right there. Now, I think it's fairly clear which section of the asymptotes we're going to land in here, just based on those intercepts. So I'm going to take those intercepts and connect them up. So this side is going to drop down and go fairly close to my asymptote to show that asymptotic behavior. And I'll extend that asymptote just to show that it's approaching that. On this other side, I'd want to plug in some coordinates just to make sure I know what's happening. So off to the right here, I'm going to change my color again, create a table. Maybe I plug in a -3 into my function so I can figure out what that's going to be equal to. So if I look back at my function, it was x squared plus 6x plus 8 in the numerator. So x squared plus 6x plus 8, and then denominator was x minus 3. So in the numerator, 3 squared would be 9, minus 18 would be -9, plus another 8 would be a -1 in the numerator, and then divided by a -6. So I end up getting a positive 1/6 for my y. So if I come back over here, that means that's going to come just above the x-axis and then come out and approach that asymptote on this side. So down here, I would extend that oblique asymptote and make sure that those come together. On the other side, I would want to plug in maybe a +4 so I can figure out what's happening on the right side of this. So in the numerator, I get a 4 squared, which is going to give me a 16. If I add 24 to that, because of the 4 times 6, and then add another 8, 16 and 24, up in the numerator is 40, plus 8 more is 48. And then in the denominator, I've got that 4 minus 3, which is just going to be a 1. So that's all over 1. That's going to be way up high here. So I'm going to extend my vertical axis, call this a 48 here, and put my point, and then recognize that as I extend this vertical asymptote and extend this oblique asymptote, this graph is going to come through here and approach that asymptote and approach that asymptote. Now, the one thing we do want to check is to make sure that we're not crossing that oblique asymptote. So if I come down here and just check one last thing, our oblique asymptote was y equals x plus 9. So if I take that function, x plus 9, and set it equal to the fraction that I had, x minus 3 and x squared plus 6x plus 8, and I want to solve that to see if I can get an x value. If I take that x minus 3 and multiply it off to the other side, that's going to end up giving me x squared plus 9x and minus 3x would be a plus 6x. And then 9 times -3 would be a -27. Set that equal to the numerator of x squared plus 6x plus 8. And notice now that x squared is going to subtract off, 6x is going to subtract off, and -27 is not equal to a positive 8, so it does not cross the horizontal or the oblique asymptote here. So then our graph is going to look something like that right there. So we found the intercepts, we found the asymptotes initially, and then we plotted what we could. And from there, we needed a little bit more information, so we used x is -3 and +4 to determine where that graph was going to be on either side of the intercepts or asymptotes. And then final thing we checked was, does it cross the oblique asymptote? In this case, no, because we got -27 is equal to negative or +8. Definitely not a true statement, so we know that it doesn't cross that oblique asymptote.